Okay, we've made it triple integrals. And there's not much of a leap from what we've been doing, as you'll see in a second here. So let's just jump right into it and do a little recollection here. We're going to link up area with volume. So let's find the area. It's my favorite problem. Under the curve, y equals 4 minus x squared on 0, 2. We've done this a bunch already. So here's the picture, right? This is the x-axis. That's the y-axis. We go from, and go like that. Okay, so here's the technique we're using in Calc 3. Right? So we start off with a ray. And your ray can either go vertically or horizontally. Doesn't matter. So one's dx dy, the other's dy dx. So we've already established that. So let's do it like this. So we emanate a ray this way. Call it L. And where it intersects there's a truck that just broke down out front here, a Lagunitas beer truck, and they're replacing the flat, so that's why it's so loud. All right, so for this integral, y goes from 0 here, y equals 0, to y equals 4 minus x squared dy. So first we do this. And then we say, all right, I want to add up all these strips. So now I go left to right, and x goes from 0, 0 to 2 dx. And this gives us area. And the general form is really area is the region R dA. Right? In this case, dA is dy dx. We could have done it dx dy, and if we want to do that, I'm not going to do it because I've done it before. Our first move would be to go like this, and then we would add up going vertically. So y would go from 0 to 4. Okay, keep that concept in your mind as we look at volume. And all volume is going to do is add another integral, right? Okay. So let's find the volume of the solid D. Where is it? Enclosed by the surface z equals x squared plus 3y squared, and z equals 8 minus x squared minus y squared. All right, so this is our example. And through the example, we're going to come up with a standard form, a recipe, if you will, for solving all of these. Okay. All right, well, every time your first move is to draw a sketch. And now it's getting hard. I actually, in the old days, I practiced right before I made this video, and I'm going to do my best to get this thing to be half decent. And you'll see that there's really two sketches here. Neither has to be amazing, but it needs to get what we need to get. So here we go. The first one, z equals x squared plus 3y squared. That thing starts at 0, 0. And it's a paraboloid because it's got x squared and y squared. And it opens up like this. Right? And then, so this is z equals x squared plus 3y squared. And then, now we're going to graph this guy in purple. And this thing opens down, so we'll put 8 right here, and it's going to open down like this. So somewhere in here, these two intersect, and this thing makes, I hope this works. Oh wow, it's working great. This thing makes an egg, for lack of a better word. Okay. So if you were looking straight down from above, this intersection of the two surfaces here, we'll call this C. This thing makes a shadow on the XY plane, right? So down here, I'm going to make it fit like that, right? And this is the shadow. We're going to call this R. Just like before. It's the region in the XY plane. Okay, so we've drawn our sketch and we've drawn our shadow, right? Okay. And right now, again, we're just sketching. This is a little messy. It's actually better than I thought it was going to be, but okay. All right, so now we're going to find z limits because we're doing triple integrals. We know how to find x and y limits. We did that to find the area. Now we're going to find z limits. So here's what you do. Here's what you do. You emanate a ray, call it M, parallel to the z-axis, coming from the south, right? So here's my ray M. It's going to intersect. Do you want it to intersect? You want it to intersect R, and it's going to come up, and then it's going to hit this guy, and that's the entrance wound. Okay. And in this case, that's x squared plus 3y squared. Right? And then it's going to go through my solid and then exit. And the exit wound is the second. Okay. That's the only new thing from this section. Because now all we're going to do is do exactly what we did and find the area of R with x and y. So we found the z limits, so 3. Find the x, y limits. And for this, we need a sketch. In the xy plane. And this one needs to be a little more accurate, because if it isn't, this doesn't work, right? So for this first ray coming up through the bottom here, all you want to do is find which function is on top of the other, right? And a dirty way to do this is, especially in this problem, if you let x and y be 0, you get z equals 8 and z equals 0, so it's clear that this guy's on top. But pictorially, this is what we're doing. So now let's find this sketch in the xy plane, but it's a really accurate sketch. So what you have to do is we have z equals 8 minus x squared minus y squared, and z equals x squared plus 3y squared. You need to set these equal to 0 to each other. Okay. So what do we get? We get 8 equals 2x squared plus 4y squared. Right? Divide by 8, because this is a ellipse. So we have x squared over 4 plus y squared over 2 equals 1. So this is the standard form of an ellipse. And here, the x radius is 2, the square root of 4, and the y radius is root 2, which is square root of 2. And its center's at 0, 0. So here's our good sketch. The accurate one. We know x is going to run from 2 to 2. So we'll make these, and y is going to run from root 2 to minus root 2. Okay, let's get some color in here. I'll use green. And so this is the region R, and it's very accurate because we have our bounds in there. That's the most important part. So that's the same region as this arm. These are the same ones. They're equal. And this one looks more like a circle, but it's actually this ellipse, which is really close to a circle. This has got radius 2, and the top is radius root 2, which is 1.4. Okay, and now we're just back to what we've been doing, finding these limits. I'm going to go left to right, just to be cool. So I'm going to enter here and exit here. So let's rewrite what we had before. We had z equals x squared plus 3y squared. Okay. And now we're going to say what? X equals a lower function here. Sorry, that's wrong. So we have, no, that's right. X equals, what is this? We just found it here. Oh, we have x squared plus 2y squared equals 4. So x equals plus or minus 4 minus 2y squared. So here's my lower bound. X equals minus 4 minus 2y squared. And here's my upper bound. X equals positive 4 minus 2y squared. There we go. So this is minus 4 minus 2y squared and plus 4 minus 2y squared. And then what does y do? Y runs from minus root 2 to root 2, right? Because we're scratching out all these. So this goes dz, dx, dy. And that gives the volume of the egg. Okay. We also could have done it. Let's find a cool color here. Green. No, we got green. Red. We also could have gone like this, right? And then our bottom function would have been y equals minus 4. Oops. I did that too fast. We got to do some work first. So we have, oops, 2y squared equals 4 minus x squared. Y squared equals 4 minus x squared over 2. So y equals plus or minus 4 minus x squared over 2. Yeah, I don't think it's any easier, but let's just finish it out. So here we're going to get z equals x squared plus 3y squared. Z equals 8 minus x squared minus y squared. Y runs from minus 4 minus x squared over 2 to plus. And then what does x do? X runs from minus 2 to 2. So this goes dz, dy, dx. And this gives us the volume. And, you know, you have to run this thing out, which takes a while. And your final answer is 8 pi square root of 2 cubic units. Yeah, it takes quite a while, but as long as you stay organized, it comes out just fine. And I don't think one is any easier than the other. So, but again, that's it. All you do is sketch the good picture along with your shadow. Find your z limits. Then draw another sketch in the xy plane, a good one. Find your x and y limits, just like before, and integrate. So no worries. Okay, here is a guided practice problem. Okay. You're going to find the volume in and above quadrant 1. It's actually octant 1, which is where x, y, and z are all positive. But we'll let r be in quadrant 1. Bounded by the surface y plus z equals 2, which is a plane, and x equals 4 minus y squared, which I think is a paraboloid. Okay, now, points for a good sketch. I'm going to make somebody show me their 3D sketch of this weird looking shape thing. And you're to find the volume all the way to the finish, and that should probably take 45 minutes to an hour. No, just a few minutes. There's no squares floating around, so the integration shouldn't be too bad. But yeah, have a go, and I'll see you in a few minutes.